Hello, everyone, and thank you very much for making it back from lunch so promptly. I should imagine that we'll see other people joining us over the next few minutes as people come in. But obviously, thank you everyone who's online and has joined us as well. We don't want to keep you waiting. We know that everyone's time is precious. So I'd like to welcome you all back to a session this afternoon, which is the first of a double header. So you've got me for another hour with a panel where we'll be looking at the integration of terrestrial and non-terrestrial networks, trying to make sure that this is something which is not just a technology piece, but something which can actually happen. And to do that means not just getting the technology in place, but making sure that we've got the right kind of commercial setups and the right kind of policy in place as well. So we'll take an hour to do that. And then after that, I'm going to hand over to Dean Bubley, who'll be hosting a discussion looking at 6G is primarily for indoor use, prove me wrong. So I'm looking forward to fisticuffs on stage for that one. And if that doesn't happen, then obviously the whole event's a washout. Having said that, let's get on with what we're meant to be here for. I'd like to invite up on stage our panel of speakers. So that's Natalia Vicente from GSOA, Yanni Tolonen from Keysight, Ethan Lin from TMY Tech, and Angelos Koulianos from the ESA. So thank you very much, everyone. Please take. Okay. So on this occasion, we don't have presentations, but what I'll do before we open up to the floor is I'd just like to get everyone to give a quick 5-minute introduction to who you are and what your involvement is when we're talking about this integration of terrestrial and non-terrestrial networks, and where you see that process moving at the moment. So Natalia, maybe I can start with you.
Thank you very much. And first of all, well, my name is Natalia Vicente. I am VP of Public Affairs at GSOA. And I want to first thanks very much because this is my first time here in the 6G Symposium. And I have to be honest, it's one of those events that you leave having learned something. And I think that is already a success. For those that maybe are not very familiar with GSOA, we are the Global Satellite Association, and we represent the satellite industry at large, from operators in GEO and MEO and LEO orbits, but also manufacturers, antennas and ground segment and launchers, et cetera, et cetera. We have over 70 members around the globe, so we are very much trying to see this in a holistic way. And I think one of the main points, setting a little bit the scene, is that indeed, and we've heard it this morning already and yesterday, there is still 2.6 billion unconnected people. And at the same time, not only focusing on people, but also on things. When we talk about connected things, we see that there is the majority of the IoT focuses on a 20% of the world, while the rest of the 80% of this world has just a few of those connected devices. And what we are seeing over the last decades is an unforeseen or a moment of innovation in the satellite industry as we have never seen before, whether it is of a technology side, but also on the services side. And I think we are imagining how the future can look like. When we talk about integration, for sure, GSOA is very active on 3GPP, and we started working as market partners already years back. And it was a milestone when we had release 17, definitely. But now it's also the moment to work on release 18 and what is the future going to look like. I really like to say that in the past, we used to work together with between the technologies. Then it happens that it was an integration phase with 5G and 5G Advanced. And maybe now the important part with 6G is precisely that unification of networks. No, we are looking at the standards already from the basis of what do we need to be integrated and be a fully seamless connectivity. And I think that is a change in mindset in different levels, not only the technology one, but also the policy one and the users one. We want things to work, whatever the technology is. One of the points that I also think is very relevant is in the past, we always talked about satellite complementing terrestrial. And I think we have to shift a bit on that concept. I think it's the extension of services. Satellite and terrestrial can provide extended services to arrive to everywhere. One of the things I liked in the Mobile World Congress, we heard it very much, and lately, is that, satellite is the only one that can provide the solution in some cases. And it's nice to hear it not from the satellite industry. So there has been this part of, we are acknowledging the benefits of each of the technologies. And I think that's where the strength of this integration comes, is pulling the strengths of the different technologies to actually provide the services that we want. What else can I say to open my remarks? Well, there is definitely a vision of connecting everyone and everything. And there is also a lot of interest on direct to device. I think everyone is excited with the possibility of having their phones working everywhere. And not only the phones, anything that is a device connected with all this world of the IoT. And I think for the satellite industry, that is also a big world of possibilities that is opening. And either it is policy or technology from the GSOA side and the association, I think there is a main way of seeing this, and it's based on collaboration at different levels. Want to also, because in the panel there's ESA, but GSOA signed a partnership agreement with the European Space Agency just this year to precisely work forward on this 5G and 6G integration, but also with GSMA, the mobile, the MNOs and the terrestrial association, precisely because we see how important it is that we work together, not only at a commercial level, but also at a policy level. Even though there will be challenges on the way, I think this is the way forward, working also with regulators and with governments. So from our side, we are excited as an industry to see how this integration will move things forward, not only for urban areas to provide better connectivity, high-speed connectivity, and so on, but also very much focus on the rural and the non-served areas, because maybe things that we have not achieved with 5G are the ones that we will achieve with 6G. If we think it that way.
Excellent. Thanks, Natalia. And having spoken about ESA, I suppose it actually makes sense to pass on to Angelos now for a quick introduction and to understand, what is the state of play from the ESA and where do you see that going?
Thank you very much, Alex. It's a pleasure to be here. First of all, good afternoon, everyone. I hope we have an exciting discussion and to keep everyone awake after the lunch break. So I would like to start on that this topic is quite timely and very important. And my name is Angelos Goulianos, and I am with the European Space Agency under the 5G, 6G non-terrestrial network team. Office, and our primary focus on the ESA non-terrestrial network office is to create solutions by means of developing new technologies, new products, and new demonstrations in collaboration with the industry, the academia, and research and technology organizations. Further, we are also driving standardization. We have initiated this satellite standardization special interest group that is the main force behind most of the advancements, release 17, and of course the ongoing release 18, 19, and beyond. Probably I need to say something quite important, that we are also designing, and we are in the process of in the next 1.5 years to launch in collaboration with the industry the first 5G, 6G satellite. So it's going to be an experimental small-scale satellite that will be capable of testing some of the features. We will have onboard payload that can resemble some of the features that are currently being discussed in the 3GPP. Least but not last, it's very important to mention that we are driving the deployment of 5G, 6G hubs across the ESA, European Space Agency member states. I have the privilege to run, to be the technical lead of the 5G, 6G hub in European Space Agency office in the UK. And this is a place for collaboration, experimentation, and technical innovation that brings together quite a lot of stakeholders. So coming back from this introduction to the topic and how we are related, it's of course generally accepted that, the satellite industry is undergoing a huge transformative shift, right? So initially the satellite role was kind of complementary role. So MNOs were mostly considered satellite as a backhaul solution. However, now we are going to another level of integration where actually the satellite technology is kind of embedded within the terrestrial technology, the terrestrial systems. And in my opinion, this is driven by the cost reduction in the end-to-end satellite ecosystem deployment, right? So we can see the launching costs have significantly dropped the last years due to the advancements in technology. And of course, there is a massive influx of the market of LEO constellations that kind of commoditized the satellite connectivity market. On the other hand, we have the advancements of standardization, where by utilizing standardization, and we can see that device manufacturers, mobile network operators find the satellite technology more attractive. So actually, they now can see the need of expanding their network capabilities through satellite rather than having the cost only as blockades. And I think these two main reasons are the driving factor for the integration of these two, until today, let's say, separated ecosystems. So to conclude, I have to say that, in my opinion, the integration of satellite and terrestrial communications is inevitable, right? But we need to be careful, I think, and take small steps because the market is still unknown. We don't understand exactly the business models and how we can navigate through these business models. We have seen companies thriving, and we have seen collaborations bankrupting, right? So we need to be very careful to take small steps in order to optimize the benefit of this convergence, but also reducing the risk to the minimum possible.
Great. Thanks very much, Angelos. Now, Ethan, I'll pass over to you and then to Yanni. So perhaps I can get you to explain a bit about your work and why you're on the panel today.
Myself, right? Thank you, Alex. So, hi, everybody. My name is Ethan Ling. I'm the co-founder and the VP of TMY Tech, which is a Taiwan-based company. We focus on millimeter wave technologies, quite a lot. That's our main focus. So today it's my honor to be here to share what we learned from the market. So I'd like to share a little bit about the startup, the history. In the very beginning, we saw that the opportunity for high band is in 5G. It's many years ago, 5 years ago. So that drive the company to focus on like a array antenna and the more high frequency technologies to fulfill that part. Since from time being, of course, a pandemic and many so on reasons, 5G FR2 slowed down globally. So by that chance, TMI Tech, we look into another opportunity, which is satellite communication. So that means we learned a lot, not only on TN side, but also we are looking into satellite side. In terms of technology, what does technology require? What kind of a specification? What's the missing part? So, but to echo Alex, the opening is that even as a technology company, we are not only resolve those challenges in terms of technology, but we always have to ask ourselves why behind, right? It's more bigger reason we need more data, why people need this, need those. From that angle point of view, they will help us to learn more about the technology missing part or the puzzle or challenges in both terrestrial and non-terrestrial networking. So I'm sure here's pretty much what I'm going to share my point of view today in today's panel. Again, thank you, Alex, invitation. This is my second time to participate of 6G Symposium. The first time was in Washington, D.C. What I can share is that 2 years ago, the 6G, it looks to me, probably it's fancy, advanced, but it's kind of buzzword. But this year, what I can feel, no, it is coming. People not only stand our side, from research and from industrial people are looking into this topic. So here we also have a booth this year next to my neighbor Keysight. We showcase a potential platform can help no matter TN or NTN technology development. Yes.
Great. Thanks, Ethan. And so Yanni.
All right. Hello, my name is Jani, coming from as far as Oulu in Finland. And for me, it's a pleasure to be here due to having the same time zone as with my family, as well as not having the insane jet lag as usual when you go to events like this. Tend to be somewhere in Washington, D.C. or somewhere like in Seoul, Korea, or anything in between. So I'm representing here the Keysight Technologies, and let me bring you on board so that you know what that actually means. So Keysight Technologies has origins in the Hewlett-Packard's test lab. So that's where it began, somewhere in the 50s, 60s when it started to take off. After some splits, company changes, it became Agilent, and nowadays it is Keysight Technologies. There are multiple of acquisitions Keysight has been doing. So for example, the product line I'm representing mostly of my time for developed and even manufactured to some point here in Finland, we have radio channel emulators. And that product line has been in Oulu for decades. So the product line has its origins somewhere in the 80s. And through some acquisitions, now it's a part of Keysight portfolio, and we have been developing. I also joined Keysight. I never actually was working for Electrobit. That was the origins of the invention for the Finnish Air Force. So I joined Keysight to drive the business for aerospace and defense. And aerospace covers anything that relates to space as well. And I have been doing space-related things before I even knew 5G NTN was a thing, even before I heard anything about it. We were working, for example, with some NASA project, space shuttle-related communications, as well as proprietary satellite. So satellite was for me already a very familiar concept when I heard first about the 5G NTN about 6 years ago. And 6 years ago seems like it's like a very short time in a human lifetime, but a lot has happened since that 6 years has passed. And I remember because also the standardization has been very optimistic to begin with the 5G NTN and integration of the satellites into cellular networks. Let's say that originally how I heard about the 5G NTN was a customer coming to me in 2018 and asking for a full-blown test solution that can integrate different parts of a satellite communication network called 5G NTN. I was like, okay, I need to look at the spec. because we usually do things a lot in advance in order to provide tools for development. And I would say that at that time, it was a little bit immature specification, I can say. And 2020, it started to mature. And we can expect those things I was requested for in 2018 to be operational and deployed maybe 2026, because it was about the broadband connections, wideband video streaming and video calls and so forth. What happened in between, actually, the narrowband IoT took over. So, because I am representing a test and measurement industry, and we need to be able to provide the ways to integrate and validate and certify things before they go operational. So we have been doing these kind of setups for entities who made the first 5G NTN calls, for example, over geo satellites about 3 years ago. Exactly 3 years ago from now. But I would say that the specification was all about different use cases, broadband connections, etc. in the beginning, and there was nothing about the narrowband IoT in those specs. Suddenly, narrowband IoT kind of was started to be recognized as a good way to start and make the initial entry into the 5G NTN. And then narrowband IoT suddenly was the, let's say, the focus and the main use case of the existing 5G NTN solutions. Let me tell you, for example, there's this Inmarsat constellation that has been there for decades, being updated, but has been deployed in this geostationary or geosynchronous orbits long time ago. And that is something that is visible, for example, here in Europe. Well, Levi is a little bit on the border. We are so much up north that, let's say that AlphaSat is quite much serving the southern Europe, middle Europe, let's say central Europe, maybe even the south of Finland very nicely. But the further north you go, it actually stops. You can't anymore listen to that satellite. You cannot have the access there. But there is one of our collaboration partners called Skylo. The Skylo is a satellite operator in Spain and operates also globally. And they came to us and said that they need some kind of a way to certify the connection modules, the smartphones, anything to go with the connectivity on their satellite network. So what we did is that we sit down with them and we start defining a set of tests required to certify whether you have compliance on that service, on that satellite connectivity and that network or not. And that was the world's first certification program there exists for 5G and still is the first and the only existing one. We are, of course, negotiating with other satellite operators. Should we do the same thing, or can we somehow expand the utilization of the certification program? So there is, for example, Deutsche Telekom in Germany, who suddenly adopted that program. And let's say that they start serving people with the satellite connections in Germany. They will go through that certification program that KeySight is offering together with these operators. So I would say that, and from the ESA, I heard this ecosystem thinking, and I really like that because when we had the proprietary satellite networks, we had the space programs from national space agencies. They were always like very, let's say, focused, centralized, and very much like closed from the ecosystem thinking point of view. Now with the 5G NTN, we suddenly have standardized way of accessing space resources, the satellites. We have a lot of entities collaborating to get that kind of systems up and running. So there usually is some kind of device vendors, ground system type of things like gateways to the satellites. There are some kind of operators on the cellular level, some kind of operators on the satellite level, and a lot of other things. And what we are trying to make here is to connect the dots so that when we are serving somebody to, let's say, help them deploy these kind of 5G NTN systems, there's usually not only this one instance running that project. Well, let's take one example. So it's not just like a some couple of buzzwords. So this is a public information because they have made their own press releases together. So for example, everybody knows Thales Alenia Space, very experienced space-related technology company. Everybody knows from the cellular networks, Ericsson Networks, because they're the #1 provider of networks for the cellular world. And then there is, let's say, everybody knows, if you have used Android phones, everybody knows Qualcomm. And Qualcomm is the #1 provider of chipsets for handsets. And all of those three companies, they are the #1 and the biggest in their area of interest, in their segment of the industry. But they joined forces in order to set up these kind of satellite calls we are talking about when we talk about the 5G NTN. So I think that sets the stage, literally, so that if you got the #1 chipset provider, #1 network provider, #1 space-related technology company, and they need their others' help to deploy the 5G NTN, that's kind of the scale of things within 5G NTN. We are providing that kind of an ecosystem, also the tools and ways to deploy, to validate and certify something that is not yet there, so that you can have, for example, a virtual satellite call before shooting anything into the orbit. But yeah, that's maybe my kind of viewpoint.
Thanks very much. So we've got quite a few different perspectives here. I will hand over to audience questions very shortly. I think it would be quite useful, though, if we just frame this. We've talked about some of those drivers for why this integration is important. We've mentioned some of the commercial reasons for it beyond purely the technology challenge because it's there. But it would be good to understand a bit about where you also see some of the barriers, because I mean it's very clear when we're talking about terrestrial and non-terrestrial, that makes them sound very unified, but clearly something like the narrowband IoT business is a world away from doing simple backhaul or even the sort of direct-to-device services, which we're starting to see come on the market now. So I think it would be really helpful to get some of your perspectives on where you see the push coming from, and also where you see maybe the most potential opportunity for commercial collaborations. And Natalia, maybe I'll start with you.
Definitely. I think we've spent the last, I don't know, 10 or even longer years with an objective that it was connecting the unconnected. No, we have this bringing meaningful connectivity to everyone. And we, in Europe, for example, we have this agenda set up for 2025, even 2020, I think there were. And now we have 2030s. And we are always postponing that date because we have not managed to get there. No technology alone has managed to connect everyone or to connect, improve also the connectivity for those that had it already. So I think that is the push behind. The technology has gotten to a point that actually things are feasible. We've heard the cost was one of the things, the cost is dropping, but also the demand from the users and from the citizens is bigger. Therefore, I think everything is kind of aligning into that moment of a push for getting things or our act together to achieve the goals that we have been setting up for the last 15 years. No? When it comes to challenges, I think, of course, there will be challenges because it's something new. Innovation brings challenges, but I don't think we should be afraid of those, but more like, okay, let's have a look at those. If there's a will, there's a way kind of thing, no? When it comes to, I think the collaboration in the industry side, it's definitely improving and getting us where we want to be. There is also a new way of engaging with the public sector that I think is very important, so that the industry and the public sector are working together into making things happen. And there will be also other challenges that come when it comes to business models. There will be different business models. There will be different things. I think we have opened the door to certain opportunities. The market is very diverse for the satellite industry also, but that means that there's a lot to be given also, that I think it's important. And I mean, we cannot hide from the fact that spectrum is going to be one of those areas that is going to still be challenging. We know from the results of WRC 23 going forward in WRC 27, 80% of the agenda is based on satellite matters. So what I think already sets the scene of how important satellite will be going forward. But also, how is it going to look like? Because now it's if we want to achieve certain things, we need to see a spectrum maybe in a different way. How can we ensure that also satellite has enough spectrum? So we have changed a little bit of the way we are looking at the tools, and I think it's the ecosystem and the public sector. It's very much willing to find solutions to those challenges, and therefore I think we sit in a good place right now.
Ethan, you're on the sort of sharp end of it commercially, so it'd be good to understand, you know, from your perspective, where you see the push coming from in terms of, you know, what kinds of companies are looking at this, and you know, again, what kind of blockers there are to that kind of progress.
Okay, thanks. So originally we focused on 5G, as I explained before. So 5G people, including operator, service provider, they look for, okay, high band, more bandwidth to provide services to end user, like smartphone, tablet, those type of whatever we already know. And next, we observe that people try to extend the business scope, of course, as we know. For example, iPhone now, the iPhone 15 connected with a satellite, provide text. So one driving force, what I see is that's number one thing, emergency usage. That's very preliminary first step to extend the business from here to here. So to provide a wider service, TMI Tech as a technology provider, we see, okay, no matter for 5G or for satellite communication, there's a common part in terms of technology, which is the array antenna. That's what we focus on. Certainly plays an important role. And what we learned from 5G experience is that's expensive originally. So probably that's also still one of the reasons why 5G FR2 high band is not yet delayed. So as a technology company, we dedicate ourselves to reduce the cost of that from many point of view, no matter from testing, design, or manufacturing point of view. So, but back to the question is with the driving force. So first I see an emergency service provide. And the second, what I can feel, observe from my point of view is that people are looking for connectivity resilience. So whenever, especially, unfortunately, there are still wars in the world. So every country is thinking about it. Maybe we should take care of this resilience, even from Taiwan point of view. The government is looking into this, right? When we talk about resilience, we have to think about different scenario. So definitely terrestrial, non-terrestrial communication, how to hand over from here to there seamlessly, provide a very robust network to guarantee the connectivity inside the country, inside the nation is still kept even during some situation. So what I can see, that's from 5G point of view. When we move pivot toward to satellite segment, okay, first what I can share is that from satellite point of view, the technology requirement is different. Of course, cost is also number one thing. But people are still looking for like a larger phase array antenna, that new technology paradigm, but satellite people are looking for a very large panel. So large panel to pick up the signal from satellite and to serve many people. Basically, that's the architect, the technology architecture people are looking for. So from satellite segment, I think Natalie, you familiar with this. You mentioned about it already. For satellite people, what do we see is, of course, we always need ground terminal, or we need a gateway to provide the service somewhere in between here and there, right? So essentially, it's already take care about that part. But when we extend to non-terrestrial, that means people are looking for the potential fusion between under the same protocol or the same framework to unify the service. What I observed so far from satellite side is not yet quite happen in that way. Of course, people take care about 3GPP and so on, but satellite operators that we work closely, people are still focused on to build up the more constellation, that infrastructure, out there. So that's from my opinion.
Right. Now, I'm going to go to you first, Yanni, because you did flag things up, and then I'll come back to you, Natalia.
I have one comment that was really good points. And from my point of view, it's about the use cases and application domain. So that when we are asking from somebody, will you use satellite connection if it is not as good as the terrestrial connection? And I think that sometimes it's an irrelevant question. So that if you have applications that rely on satellite connectivity, the all existing coverage, for example, for the whole globe, and you drive your application and use case based on that fact, it becomes obvious that we will have those satellite networks in place for those kind of applications, sensor data, any kind of IoT. And that was one of the reasons why the IoT kind of took over. It is easier to deploy. It is having applications that are not competing maybe against our video broadcasting or video streaming or even voice calls, what we are using mobile phones typically for. But that is still, I think that is one of the use cases. And then those governmental driven services, emergency services and so forth, they are also obvious use case for those new networks that are all around and everywhere. I heard from somewhere that who is going to use a satellite network if the broadband, the definition of the broadband from FCC is, what it 200 or 400 megahertz or megabits, or how do you want to say it? From RF people, it's megahertz. If you ask from digital people, it's megabits. Anyway, it's usually nowadays about the same what you get. So if you have a 5 megahertz link, you get about 5 megabits of throughput with the modern modulated signal. So good to have those kind of rule of thumbs, by the way. It's easier to explain for every man. So I would say that kind of the coexistence of the networks, we will be most of the time still using the terrestrial networks. When you need the high bandwidth, high throughput link, you have, for example, here in indoor, you have indoor nodes. And satellite is very not that easy even to deploy here in the indoors. But I would say that it's about that use case, and it's a very good thing that the business aspect has been taken also into the discussion, because it will be the thing that whether it makes or whether it's not gonna make it. What are the use cases that people are willing to pay for? But also what are the use cases from the governmental use case point of view, which will drive the deployment of those networks? And I think it is eventually there, and I think we cannot stop it.
Natalia.
Yeah, so if I may, because I think, I'm not sure we are thinking, or if we are going a little bit backwards. I think every technology has qualities, and satellite has the ubiquity quality, the coverage, the reliability indeed. And I think it's not one or the other, which one are we going to use more? Or if we ask the consumer, do you want to use satellite connectivity? as a consumer, probably I don't care. I just want it to work. That's the only thing I want. Do I need 400 speed? Shall we put more and more numbers just because technology can manage to do it? I mean, I don't think that is the purpose of what we are trying to do. We need to consider that there's
There one?
people, I mean, I don't have that those speeds at home and I live in the city, and I don't think that all the use cases require that. I think precisely that's where we need to focus is what does the market need? And I think with the integration, what we are trying to precisely achieve is anything. We can do anything. And it's not about the speed that it comes. It's not about only the latency. I also think that we need to think about satellite technology, what it is now and what can it become, not what it was. Because we tend to think about satellite as that older technology, let's say. It has advanced. It's moving forward. I invite very much to see some of the projects that I very much like from my members. Sateliot is one of the companies that is providing or is working on the integrated integration of technologies, specifically for IoT, in which all the gateways and everything else, it's quite simplified. That is very interesting, but it's also about the geo and the evolution of the geo satellites and what can they provide, not only backhauling or space powered, but if we think about it in an integrated way, what can we provide? No, so I think it's the use case for sure, but it's also pulling the benefits of the technology without thinking if it's terrestrial or satellite. It's just what can you give me as a technology, and let's put that together with what I can give and provide the service. And I think this way we definitely will benefit not only the connectivity or the direct to device and emergency, but it will help also to use the resources, the natural resources more efficiently, because we will manage to get the connectivity in other places. Some of the examples that I love are related to the oceans and the well-being of the oceans and the biodiversity. So I think there's endless possibilities for all the technologies together within a building. Of course, satellite is not the most suitable solution, but it's part of the ecosystem. That's how I would see it.
Okay, excellent, thank you. And I'd like to open up to the floor at this point and make sure that we've got the chance to have you ask your questions.
If I can have a moment on this, please, to complement some of this, because I would like to, first of all, to give some comments on what has been said. I concur with what Natalia said. So I think, so what we try to do here is integrate terrestrial and satellite communications, right? So I think the satellite communication ecosystems needs somehow to decouple from the use cases, right? We keep on thinking use cases. If you come along and think what the mobile network operators are serving, right? They serve everyone. So they serve young people, old people, they serve emergency calls, they serve high data throughput, video, everything, right? So this is a point I would like to say, that we need maybe change a bit the perspective how we see satellite communications, right? Second, it's very important to say maybe some of the challenges that we need to face. So firstly, there is the regulatory aspects. The spectrum aspects were discussed yesterday in the spectrum session. We have seen an initiative in the United States. The FCC has recently approved, let's say, a new framework that you can use, satellite operators can use terrestrial spectrum from space, right? This was called complementary coverage from space. But what happens in areas that have smaller geographical territories, like Europe, right? So in Europe, the spectrum is fragmented. You can have one operator working in a certain set of frequencies in one country and another set of frequencies in another country, right? This will create a lot of interference. So how do we work around this? I think WRC 27, this is going to be one of the major aspects to be discussed, how to create a harmonization of spectrum in Europe. Thirdly, I would like just to mention this one. So the technological challenges are very important. The satellite ground segment, let's start with the ground segment. The ground segment is completely let's say, architectured in a completely different way from the typical standardized 3GPP interfaces that MNO are currently complying with, right? So when we talk about satellite, let's say, operators kind of working in a roaming fashion, so how this is going to work since the interfaces are not low? What kind of language will be used to communicate between each other? So we need to work around what kind of interoperability aspects needs to be built around this. And fourth is the policy, right? So it's very important. Security is the #1 factor currently. And what happens with lawful intercept, right? So if we want to extend MNO's coverage over satellite, who is handling the lawful intercept? So you have a user in Spain and maybe the gateway is in France, right? If we want, let's say, to intercept the call in the ground segment in France, there's going to be legal, let's say, agreements between the two countries. And this is not easy. It's quite complicated. Okay, I will stop here so we can take some questions. Yeah.
No, those are some very good points. And I'm going to give people a couple of seconds to raise their hands. Otherwise, I do have some things I'd like to pick up on. So, okay, we have a question just here in the front row. There is a, what do you call this, microphone coming over to you.
Hi, Aki Nakao, the University of Tokyo. Thank you very much for your sharing your valuable views on NTN. I have a question about market, the future market of NTN, because every country has multiple telcos and creating a healthy market, I think. But when it comes to NTN, so right now we have Starlink, which monopolizes the market of low Earth orbit satellite communications. But in future, if someone doesn't have, the good amount of investment like Elon Musk, right? So then, this monopoly of the market would continue. And what do you think is that, what would happen to this NTN market in the future? Is it going to be a healthy market? Or if not, so then what, can we do about it? I'd like to hear your opinions.
Angelos.
Yeah, just to give you my overview on this one. So currently there are 3 different market models, right, in the field. So first of all, we have the newcomers that exploit existing terrestrial spectrum from space, or they are trying to exploit terrestrial spectrum from space. So we have the device manufacturers that are actually, what they're trying to do is extend the device capabilities over partnerships with, let's say, satellite operators. So you can see this example like Apple Globalstar, as Natalia said. So we have also the Huawei Beidou agreement. We have some other smaller companies that are trying to do the same. We have the device manufacturers, right? So Qualcomm, MediaTek are trying to comply with 3GPP and IoT standards and collaborate with MNOs, SNOs, service integrators, and so on and so forth. So, I think we are still in very early stages. We don't quite understand what is the business, what is the successful market. So, for example, who is the provider, who is the customer, and how profit will be made. So if I give you an example, so for example, are we doing the profit through selling more devices? Like, for example, Apple is selling more devices and compensates for the investment in the new chipsets they had to do. Are we expecting that as MNOs, let's say the MNOs will attract more subscribers because of the new features? So this is what AST Space Mobile is trying to do with Vodafone, NTN, Rakuten in Japan, and so on and so forth. So there are quite a lot of business models to discuss. And the third one is where there is kind of the NTN enablers that collaborate with, like it was mentioned, Skylo, right? So collaborating with manufacturers, device manufacturers, MNOs, SNOs to create an ecosystem that is compatible to the standards. I think, just to conclude my thoughts, I think what we need to do is go back to the terrestrial market and understand what made the terrestrial market successful, apply the same concepts in the satellite market, right? So for example, if you go back to the terrestrial market, you will see that there was a high penetration because there was economies of scale were being employed. The question, in my opinion, is how we employ economies of scale in the NTN market, right? So you can see an abundance of new constellations and Starlink, as you said, monopolizing, but I think there are other initiatives there. There is Link, there is AST Space Mobile, so we're getting there. And the most important thing is when we try to commoditize the market and create, let's say, economies of scale, this will go back to the fact that the economies of scale will create a kind of a system that will essentially provide more elasticity in the market. And when the market is quite elastic as with respect to pricing, right? So if you create economies of scale, this creates elasticity in the market and bigger penetration.
Yeah, and if you think about the global broadband, you first start thinking about Starlink very easily because they already provide that global broadband. But there might be other business models also, for example, very low number of satellites, non-continuous service for, let's say, sensor data or IoT. You might have global coverage with as low as, let's say, 4 satellites, 2 orbital planes, and you would do business on top of your satellite network, doing a non-continuous moving bits around from sensors or other low bitrate applications. But there are also these competing, let's say the AST Space Mobile case is a very interesting one, because from the device vendor point of view, they are trying to do something that is maybe a little bit not very highly appreciated, is that every phone that exists as of today could access that satellite network. It's a very good business for operators due to the fact that the installed base is already like 100% coverage.
Yeah.
You don't need any special device. You take your LTE phone, and the AST Space Mobile spaceborne platform has sensitive enough antennas to read your signal from the cell phone, and they have enough power due to the huge size to beam down that much power that your phone doesn't recognize whether it's connected to the landmass cellular network or the space network. But
maybe Starlink, maybe T-Mobile, so those companies are competing probably in the future. But the non-terrestrial, enhanced mobile broadband service. So right now we see only one choice, and I'm a little bit worried that this situation would continue. So then we don't know if we can create a healthy market in that one. So,
I suspect that's probably more of a question to Natalia as to whether you see any opportunities to be encouraging competition in these markets where there are high barriers to entry.
So I think there's definitely some players that have moved faster than others. It doesn't mean that there's no other operators that are looking at the same style of business, and I think we need to just wait a bit. Of course, there has been first movers always, but there's also the ones that come next, and how are they going to do it, and what's going to be the added value. As you were mentioning precisely, it's not all about the consumers per se. There's going to be other kind of constellations. There's going to be other services, and there will be competitors too, as there has been. And I think there's every region is trying to push on this healthy competition also. And I believe that we need a flexible framework, policy framework that precisely fosters that competition, healthy competition, to provide the services, and that we can continue working on open standards for the economies of scalability and so on.
Brilliant, thank you. Now we have about 2 minutes left, so I'm going to get you to ask your question and then.
Yeah, so this is actually not a question, this is comment to what we were discussed, just that whether we are going to have a healthy ecosystem with the NR, NTN. And I'm from MediaTek, so I think that there's a probably we, and also I'm not, of course, able to talk about on behalf of Qualcomm, but I think that the thinking is that we would like to make, let's say, we would like to integrate the possibility to connect to the NTN 3GPP open standard based technology as affordable as possible. And in a way, you have seen some devices where we have MediaTek IoT NTN enabled already. So that's just modification of our RF and chipset. You do not need to buy a second, what do you call it, like a technology, what the proprietary systems are. So we are very strongly pushing for this, let's say, open 3GPP based solution. And whenever you have the, let's say, affordable satellite connection with everyone's pocket, we are willing to sell 300 million devices a year which are NTN enabled. Then I think that will create the demand as well. When you have the technology, we have enabled this satellite connectivity. That's where I think that where we should all push instead of Starlink dominating the market.
Yeah, and if everybody remembers how the SMS became a thing and GPRS data connections, they were technologies that existed and people took into use surprisingly nicely. For example, the text type of communication suddenly became a thing after NMT phones had only the voice. So I think if we have, very nicely said, if we have the technology available, people will find use for it eventually, even though nobody would be pushing for it. But yeah.
Yeah, there's some.
But that's
one bit.
just quickly.
Yeah, a quick one. So echo to this. So people, I think the facility is here already. It's not only a mobile program, of course, the Starlink is building more and more. But from satellite point of view, the facility is there. The business model or new market, I think we have enough technology and the bandwidth to create something new. So nothing stops us. So that's what I'm trying to say, actually.
Excellent, thank you. Now, I'm very aware of time pressing on, and we've been discussing some very high orbit conversations here. We're going to take that in entirely the other way and look at indoor service provision. So I'd love to carry on this conversation, but it may be something that we do over coffee. For now, can I ask everybody to give the panelists a round of applause?